Okay, next part of the review is going to be the Pythagorean Theorem and its converse. Now the Pythagorean Theorem, we've talked about a squared plus b squared equals c squared. It's the ratio of the squares of the sides of a right triangle. We talked about how those are related to the areas of the squares that are formed if you make each one of those sides a square. So it's the areas, and we've talked about that in class extensively. Finding the value of x. Well, first of all, let's use the Pythagorean Theorem. And just to kind of give you an idea, again, I guess we'll go ahead and talk about it. You have a right triangle. The Pythagorean Theorem comes from the idea that if I drew squares off of each of these sides of my right triangle, the area of this square plus the area of this square equals the area of this square. That's where the a squared plus b squared equals c squared element comes in. And remember, a and b are the legs, c is the hypotenuse. So let's look at number 20. Number 20, we have two legs. And remember, leg squared plus leg squared equals hypotenuse squared. That's our rule. So I have 6 squared plus 5 squared is going to equal x squared, because x is my hypotenuse. So 36 plus 25 equals x squared. 36 plus 25 is 61, which is x squared. And then what do I do to find x? Because I don't want x squared, I want x. I'm square rooting both sides, so x is equal to the square root of 61. Now, we don't have, 61 is not something that has a perfect square factor to it, so that's not something that we can simplify anymore. If you actually want to get the exact value, then you would do second, let me find it here, square root of 61, and you'd get 7.8. So 7.8 is the exact value of that side. But if we leave it in radical form, it is square root of 61. Okay, so let's look at 21. Now if I look at number 21, I'm given the hypotenuse this time. So I have a hypotenuse and a leg. I don't have two legs. So I could set it up, x squared plus 7 squared equals 13 squared. And that's what you would normally do if you were doing two legs. There's a shortcut though. If you have the hypotenuse, you can skip this step, because ultimately what am I going to have to do anyway? Subtract that 7 squared over, right? So it's going to end up being 13 squared minus 7 squared. So when you have the hypotenuse, you can just subtract. X squared equals 169 minus 49. That's going to equal 120. And then what do we do to both sides? We take the square root. So as x is equal to the square root of 120. Now we talked about simplifying these guys. Oops, let me scoot this over for you a bit. We talked about simplifying. If you remember, square root of 120, that's 10 times 12. 10 is 2 times 5. 12 is 2 times 6. And 6 is 2 times 3. If we wanted to simplify this, we could look for the pairs. I've got a pair of 2's, but that's it. So that would be 2. And then the pair, for every pair, 1 comes out, and then you remultiply everything together. So 2 square root of 30. If you want to do that without simplifying, and you just want to do second square root of 120, you get 10.95. So that could also be 10.95. So those are your two possible answers. And it depends on whether it asks you to simplify it or not. But remember, if you want to simplify a radical, we took a test on this, you factor it out to its prime factors. We had a pair of 2's, so for every pair 1 comes out. Then I had 3 and 5 and 2 left underneath, which is square root of 30. If you multiply that out, you'll notice it is 10.95. So that's applying the Pythagorean Theorem. Now, on the other side, so this gets really messy because you can see all of my fun little scribbles from the other side. Determine whether the three lengths form an acute, obtuse, or right triangle. This is the converse of the Pythagorean Theorem. Now remember, the converse gives us several things to keep in mind. If c squared equals a squared plus b squared, it's a right triangle. Remember that? If c squared is less than a squared plus b squared, it's an acute triangle. And if c squared is greater than a squared plus b squared, it's obtuse. So that's what we're going to do with each of these. And in each case, remember, c is just the largest value. So here I've got 10, 12, and 13. So 13 is my c. So I'm going to compare 13 squared to 10 squared plus 12 squared. So that's 169, that's 100, that's 144. So you have 169 and 244. So c squared is less than a squared plus b squared. So this is an acute triangle. Okay, so let's look at 23. 23, 15 would be c because it's the largest. So I'm going to compare 15 squared to 12 squared plus 14 squared. That's 225, 144, 196, I believe. Remember, I got to check these things out because I don't want to tell you the wrong thing. So I got 196 and 144, which is correct. So I have 340 and 225. So c squared, once again, is less than, so this is also acute. If c squared is less than a squared plus b squared, it's acute. So let's check the last one. 10 is obviously c because it's the largest. So I'm going to compare 10 squared to 6 squared plus 8 squared. I get 100 equals 36 plus 64, and I ended up getting 100 equals 100. So this is a right triangle because c squared equals a squared plus b squared. Now if it's obtuse, c squared all by itself would be less than greater than a squared plus b squared. So that's the converse of the Pythagorean theorem. Okay, so now let's look at geometric mean. And then I'll can this video after geometric mean and we'll move on to I'll make the other one another video. For geometric mean, remember the altitude of a right triangle becomes the geometric mean of the right triangle. Okay? So this is the geometric mean. And I'll call this G. There's a little g. That's pretty funny, right? Never mind. So this little g is the geometric mean of this guy and this guy. So 9 over g equals g over 16. You guys remember that? The geometric mean is the value that is the denominator of one fraction and the numerator of another that makes them equal ratios. So when I cross multiply, I get g times g, which is g squared, and 9 times 16, which is 144. I take the square root of both sides, so little g is 12. That's your geometric mean right there. Okay? Now, let's look at the next one, okay? The next one here, we have the altitude here, but we've got 16 and 25. Well, remember we showed you that trick of opening up all of these and creating the 3 similar triangles? And this is something that you guys had to visualize the orientation, okay? So we have to visualize these 3 triangles. This is the bottom leg of the medium triangle, okay? Thank you, honey. Sorry, my son is in here. It's the big leg of the small triangle. 16 is the big leg of this triangle, and 25 is the hypotenuse of the big one, okay? Which also means if the whole thing is 25 and this is 16, this is 9. Y'all go to bed, please. So this also means this is 9. All right? Okay.
My watch has no grip.
So this is the geometric mean, sorry, I have got company, of these two guys. All right? So 9 over x equals x over 16. Okay? So I've got x squared when I cross multiply, again, equals 144. I don't know why they would give you the same value, but they did. And when you square root it, you get 12. Now, it's not always going to be 12. I don't know why it happened to be in this particular example that it's both 12, but it's not always going to be 12. Okay? So you're looking at it at the same perspective, okay? So you always look at these as the altitude is the geometric mean of the 2 pieces of the big hypotenuse.